In this video, we'll be given information about the magnitude and direction of vectors, and our job is to find those vectors. So let's do that. Here's the first problem. Find the unit vector in the direction of a vector, that's I cap plus j cap plus 2k cap. So we're given a vector, a vector, and we need to find a unit vector. Unit vector means this vector will have the magnitude of 1. This vector will be in the direction of a vector. So pause the video. Think about how you'll approach this problem. Okay, so let's first find the magnitude of a vector. This is going to be square root of 1 square plus 1 square plus 2 square. That's 1 plus 1 plus 4, that's 6. So the magnitude is square root of 6. So this vector has a magnitude of root 6. But we need a vector which is in the same direction but with a smaller magnitude. We need the magnitude to be 1. How do we do this? Well, we can divide this vector by its own magnitude. That way, this magnitude, this new vector will have the magnitude of 1. So dividing a vector by mod of a vector should give us the unit vector in the direction of itself, a vector. And I like to call it scaling down. So we're scaling down this vector. We're finding a unit vector in the same direction. That's a vector divided by its magnitude. And we can write this as a cap. Anything with a cap over it means we're talking about a unit vector. So a cap is going to be a vector, which is I cap plus j cap plus 2k cap divided by root 6. So if we divide this vector by root 6, we're dividing all the components by root 6. So this vector that we're trying to find is 1 by root 6 I cap plus 1 by root 6 j cap plus 2 by root 6 k cap. And you can find the magnitude. If you square and add, let's see what we get. 1 by 6 plus 1 by 6 plus 4 by 6, that's 6 by 6, which is equal to 1. So 1's root is 1, which means this is indeed a unit vector. So this is how you can find a unit vector in the direction of a given vector. Here's another problem. Find the vector in the direction of a vector, which is 5i cap minus j cap plus 2k cap, which has a magnitude of 8. So in this case, we don't want the unit vector. We want a vector which has a magnitude of 8. So pause the video. Figure out how you'll solve this. Okay, so what we can do is, if we can find the unit vector, we can scale it back up, and this time we'll multiply it by 8. This is the magnitude that we need. So let's do this step by step. Let's first find the magnitude of a vector, mod a vector. That's square root of 5 square plus 1 square plus 2 square. That's 25 plus 1, 26 plus 4, 30. So this is root 30. This vector has a magnitude of root 30. Now let's scale this down. If we scale this down, we'll divide this by its magnitude. This is a cap. That's a vector by root 30. That's going to be 5 by root 30 I cap minus 1 by root 30 j cap plus 2 by root 30 k cap. So now we have a unit vector in this direction. But we don't want the unit vector. We want this vector to be having a magnitude of 8. How can we do that? Well, we can multiply this unit vector by 8. So we can scale this back up. So this new vector, this green vector is what we need. This is equal to 8 times the unit vector, 8 a cap. That's going to be 8 times this entire thing. So this is going to become 8 times 5, 40. 40 by root 30 I cap minus 8 by root 30 j cap plus 16 by root 30 k cap. Now this vector has a magnitude of 8 and is in the direction of a vector, because this is what we've got by scaling up the unit vector. So this is how you can find any vector of any magnitude in the direction of a given vector. Here's another problem. Find the vector of magnitude 5 parallel to the resultant of these two vectors, a vector and b vector. Pause the video, try this out. Okay, resultant means we are adding these two vectors. First, let's find the resultant. That's going to be a vector plus b vector. That's 2 plus 1 I cap plus 3 minus 2 j cap plus minus 1 plus 1 k cap. So that's going to be 3 I cap plus j cap plus 0. So this means our c vector, which is the resultant, that's 3 I cap plus j cap. What do we need? We need a vector of magnitude 5 in this direction. So let's first find the magnitude. Finding magnitude is going to be root of 3 square plus 1 square, that's root of 10. So mod of c vector is root 10. We can scale this down. So scaling this down means dividing this vector by its magnitude. That's going to give us c cap. That's c vector by mod of c vector. That's 3i cap plus j cap divided by root of 10. So this is our unit vector. Now we can scale it back up. We need a magnitude of 5. So we'll multiply this unit vector by 5. So this is going to be 5c cap. That's 5 times 3i cap plus j cap divided by root 10. That's going to give us 3 root 10 by 2 I cap plus root 10 by 2 j cap. Let's solve one more problem. Find the unit vector in xy plane making an angle of 30 degrees with the positive x-axis. So the magnitude is 1. We're looking for a unit vector. And for the directions, we're given some angle with some axis. So pause the video, try this out. Okay, so we need to be careful with the direction. Angle of 30 degrees with positive x-axis, which means alpha, that's equal to 30 degrees. And this vector is in xy plane. This means it's perpendicular to the z-axis, which means your gamma, that's actually equal to 90 degrees. The angle that it makes with z-axis is going to be 90 degrees. This means we're actually in the 2D plane, the xy plane. If the angle that this vector makes with x-axis is 30 degrees, it should make a 60 degree angle with the y-axis. 30 plus 60 is 90. So these are our angles. We can find the cos of these angles and get our unit vector. But to be double sure, let's find the value of beta. Let's find the angle that it makes with y-axis using our relationship between cos of these angles. So let's find direction cosines. We know cos of alpha, that's going to be cos of 30, that's a root 3 by 2. Cos of gamma, that's going to be cos of 90, that's 0. Now we need cos of beta, and the relation that we have is L square plus M square plus N square equal to 1. So we can plug these values. We have 3 by 4 plus M square, this is what we need, plus N square is 0. So M square is going to be 1 minus 3 by 4, that's going to be 1 by 4. And if we take a square root, we get 1 by 2. So cos beta equals to cos of 60 because cos 60 is half. So this also shows that our angle is actually 60 degrees. All right. So we have the angles and the direction cosines. Now we need to find the vector. So the unit vector is actually Li cap plus Mj cap plus Nk cap. We can have the direction cosines as the components. So L is root 3 by 2, M is 1 by 2, and N is 0. So this is going to give us root 3 by 2 I cap plus half j cap.